Hello to viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about hybrid electric aircrafts. So let's dive deep into it. Now, what exactly is the problem? We just talked about electric aircraft, but reality is aviation, like the basic aviation we think of. These puppies are hungry puppies, meaning they consume energy like there is no tomorrow. Specifically, that last one, Airbus A380. So it's so much energy draw. As of now, electric vehicle on paper cannot even touch this. Like, no. Meaning if you made it, it will not take off because it will be too heavy. And if you made it light enough, it will take off, it will not have the range. So under the known laws of physics and under the known chemistry, as of now, 2025, if you try to do this, it's a nope. Like, you do not even waste time on it. It's just like, nope. So let that be very clear. Now, many people will say, what if future energy happens? But here's the deal, you have to understand. Fuel is very energy dense, like ludicrously energy dense. The reason we don't go kaput every time we use fuel is simply because it's a half component. Let that be very clear. You must have studied this in school. Fuel is not complete. It requires oxygen from the atmosphere to work. Now, how do we get that oxygen? Well, we don't get pure oxygen. That's the another safety component. Not only it's half, the oxygen, it's not pure. You get it submerged in nitrogen. That's why using combustion with fuel is safe enough. Even though the fuel, it's bonkersly energy dense. How do we know it's bonkersly energy dense? If you put it with liquid oxygen, test it. It becomes a rocket engine. We know it has more than enough power. Now, whenever you are talking about, let's say, a magical battery, let's just say quantum capacitors, it has all the energy, which, mind you, it will require twice the energy density of fuel. Now, like, why? Well, fuel gets lighter as you use it. For example, Airbus A380 can lose upwards of 150 tons, or actually more than that, while it's traveling on its long distance flight. Let that sink in. This puppy will take off and it will lose 150 tons and then it will land. It's like, I'm so light. That's the reason why those planes can fly. Batteries do not have that luxury. So if you have to compete with Airbus A380 in terms of its raw capacity and range, yeah, it needs to be 2x. So fundamentally, if you can find something that has that kind of energy, it's a very big boomy device, and it's under the known laws of physics. If you have so much energy crammed into a small place and it has both of the components, any minor inconvenience will become a boom event. That's why fuel fires are actually manageable by firefighters, but they can't do anything about electric fire, even though electric fires have much less what you call total oomph. It's just that you can't cut oxygen. It has its own oxygen. It's like, I got this. I will burn. I'll burn underwater. I'll burn for a month. Not even joking. So, and be mindful, we have learned this the hard way. Steam trains, right? We used to there was an era, like late 1850s and 1890s, things happened and people are like, whoa, let's put more pressure, more pressure. They became so dangerous at certain point, certain accidents wiped out a station. And it's steam. It's not nuclear, it's steam, but that's the whole law of physics. The more energy you cram into a position and the more it has every component that it needs, the more unstable it becomes. So if somebody in future makes a battery, I will be like, if you're married, then sit. Then it does not matter. But that's the whole point of it. So fundamentally, as of now, for small craft, we can't touch these things. Like, these things are so fine-tuned, don't even think about it. But about commuter crafts, basically craft that are made for regional travels, those we can touch. But again, electric does not have range. But with hybrid, we can take care of it. Now, which kind of fuel we want to use? Well, hydrocarbon. And if you smoke, then you can say hydrogen. But you cannot use hydrogen. Hydrogen does not have the density needed. Now, since most of you have never looked at a periodic table, look at periodic table again and pay attention where hydrogen is. So if you want to make you stupid, I will say hydrogen has 120 megajoule per kilogram. Is that statement scientifically accurate? Yes, factually true. You just don't carry things in kilograms. You carry things in liters. Basically, how do you think the fuel tank capacities are measured there? Heck, how the fuel tank capacity on a CNG is measured? How the heck fuel tank capacity is measured in a hydrogen tank? It's always in liters. That's much of volume you have. So now if you compare that 1 liter, let's say I give you the best hydrogen, which again Airbus is trying, not because they want to, because European Union smoked and they're like, we're gonna ban hydrocarbons. So they're like, yeah, okay, you're gonna burn for it. So they are using liquid hydrogen. That has 8 megajoule per liter. That's it. And how much you have with petrol, diesel, above 30. So JP8 is like around 30, 35. So don't worry about it. That's why you can't fly on hydrogen, liquid hydrogen. That's why rocket companies are like, yeah, liquid hydrogen is not worth it. They're all switching to methane. Unless you have carbon binding hydrogen, density of usable hydrogen is so low, it does not matter. And again, if you ever became retarded enough where you're like, no, it has higher efficiency, compare how bad the efficiency of jet has to be so it can be dropped down to 8. And be mindful, hydrogen will not give you 100%. So assume 100% of hydrogen, 8. Compare how much you have to drop down, and these things have crossed it. So yes, you cannot do it on hydrogen, but if you are stupid enough, I will sell you one. Heck, I will make an engine and I'll sell you it. It's just that if you are stupid, I'll take your money gladly. So pay attention to this, and it's available in every encyclopedia, every hydrocarbon book, every fuel book, every school, every library, every college. We have been doing this from 1800s. So let's look at certain companies' option, how they are trying it. Well, AMPAIRE, this is a small company that is done it. Basically, they took Cessna and they're like, okay, what if we add it to it? So they took a Cessna and they're like, okay, they modified it with pusher and puller configuration. And I'm like, why? Well, they needed two things. Now, internal combustion engine is very efficient if, let that be very clear, all internal combustion engine, if made in modern times, is really efficient. If you can put it as a sweet spot. It's very sensitive. The sweet spot is very sensitive. It requires precise RPM, meaning the RPM zone would be, let's say, for this engine, 1250 RPM. It has to be there, 1215 RPM. It has to be there. It cannot go below or up. And in terms of torque, it will be fixed. Like it has that many Newton meters. It has to be that. It cannot go up or down. Efficiency will suffer if you do that. It's nigh impossible to do. That's why our combustion real life efficiency is never good. But what if you have an electric that is boosting it? Now you are talking about something when you are doing takeoff and climb, which is the most energy intensive part. Combustion engine is not going, it's like, I got this. Electric motors like, yo bro, relax, stay efficient. We can't buy more fuel. You stay efficient, I'm going to provide the extra oomph you need. And when it becomes the other way around, when you are actually climbing and cruising, everything is fine. It's like, yo, it's reaching a point where it's not efficient. It's like, bro, you just provide power, which is excess. I will drain the power from you because of generator and I'm going to charge the battery. You just chill. So fundamentally, how much energy savings they can do? They have already built it, tested it. So far, they have achieved 40% fuel reduction. That is shut up, take money. And again, how the heck they can achieve it? Well, because the batteries are small. If the batteries were huge, the weight penalty would compensate for any gains you can get. So there is a sweet spot. They have to basically do the calculation. So they have successfully managed 40%. And again, let that be very clear. If you ever looked into brake-specific fuel consumption of an engine, you will be shocked how efficient our current engines are. We just can't utilize the efficiency. And that's why I've been screaming, use series hybrid. So you need 40%, they gain 40% more. Now, they are focusing on commuter aircrafts, push and pull configuration, and their future designs are this puppy, which is single prop. Why would you want to go to single prop? If you have single prop, you have less drag penalties. So they are doing that. How they are doing it? They have an engine and they have a basically hollow shaft coaxial motor. That puppy allows them to compensate for it. Basically, if they need more torque, the RPM can't change because RPM is coupled to the shaft. So they are changing the blade prop angle, so to say. You can find the diagram of this in the brand. So basically, propeller loading is now independent from torque loading wise. RPM is fixed. You can't do much with the RPM, but torque wise, that motor generator unit is like, I got you, fam. So if engine produces too much, it's like it leaches energy. If it produces too little, it adds energy to it. So engine always remains at the optimum point, and you do not have the penalty of having two propellers. Now imagine with two propeller penalty, they manage 40% saving. How much with this? They are claiming 70%. They have not flown, like they built it, flown it. It's just that they are waiting for verification flight and all that jazz. And this is their future concept where they're going to have pusher crafted design. It will be even more efficient. Can that happen? Yes. So would it have a big enough impact? Yes. Like it will have big enough impact. And be mindful, it also improves safety, meaning if you are in a scenario where combustion engine kaputs itself, you have electric to fall back on. If your electric kaputs itself, you have combustion engine to fall back on. So fundamentally, this would be a bit more reliable. Not too much reliable, but bit more reliable. So this is what they are doing. They have made it. The company, I think, started uploading videos 4 years ago. They have made it, flown it, things are done. They are moving on to the next decision. This will be their, I think, actual production one, and that is their future concept one. So this is AMPAIRE. Now we come to Zuri VTOL. Now this puppy is utilizing tilt rotor. They are like, hey, we are doing so much extra work, why not just make it VTOL? Now you have to fundamentally understand, VTOLs are not efficient simply because unless you are a tilt rotor, tail rotor design where you go like this, you no other designs can give you benefit of it, because even with this, you're like, okay, can't it just like tilt it and have benefits? Yes, it will do the vertical takeoff and landing. That's the cool part. Penalty is it's too much mass. Where that mass is coming from, that hinge and the mechanism to move those this hinge puppy, yeah, that adds too much mass. So there is a penalty. That's why I said if you have a tail seater craft, or what we call direct takeoff systems, those are the best. But this is the second best you can do, because you have so many hinges and so many mechanism to move them. It will have a penalty, but it's still better than nothing, because when you are doing horizontal flight, let's say take off, how long you going to take off? It's like few minutes, right? Not even few whole minutes. It's like take off and then you switch to horizontal flight. So when you are majority of the time, those are just straight weight, but you have the aerodynamic efficiency of flight. That's the reason why aeroplanes travel further than helicopters on the same fuel, simply because it's far more aerodynamic to travel on wings. So this puppy gives you best of both worlds. It gives you vertical takeoff and landing, and it gives you low drag flight path. So that's the awesome part. Now they have battery powered 8 tilting prop systems, 8 of them. It's a bit much, but it's their design. And how the heck they are providing power? Well, battery can provide this power, but again, only for minutes. And turbo shaft engine is the generator supply. So they have a tiny generator. You see the exhaust of it. So that puppy is the main oomph. And because of the fact that they can keep the turbo generator isolated from the load, and battery is handling all the buffering, they can get much higher efficiency. Now compared to electric system, there is no discussion here. This puppy, if it can fly from Berlin, it will land to Amsterdam. So it's magnificent range, as in 700-kilometer range plus 30 minutes of reserve. Again, all long-range crafts have to have that. Basically, Airbus A380 never flies when the scenario is like, oh, that distance is 2 hours, I'm gonna take fuel for 2 hours. No, it must be 2 hours plus the buffer time, based on the law, based on the regulation. So they have like a lot of fuel load. So this has the same thing, where it's like, yeah, if let's say a location is 600 kilometers, it's not that after fuel low, emergency, land, mayday, no. It's like, yeah, we have time. So 30 minutes reserve. EV cannot even try that. Let me be clear. You can make an EV that can fly. It will look almost like this. The moment you talk about range, no. Because batteries have made amazing progress when it comes to kilowatt. Basically, the power rating is bonkersly awesome. Motors, bonkersly efficient. That part is sorted. The moment you touch the capacity is like, nope. Fuel is like, bruh. Don't even compare. So fundamentally is there, and it has much less emission. Same way as the last design, like fundamentally much less emission. If you move that many people using an aircraft, this will have less emission, and it will give you VTOL. So that's the whole point. Turbo shaft engine stays at the sweet spot. So again, long range, like it's actually long range travel. So that's an awesome addition they are doing. Then we come to Electra. This is a bit different design, and they are like, no VTOL. We are not doing VTOL. Again, adds mass. So they are like, what if we do ultra short takeoff? Meaning you take off from runway and you just like, yeah. Done. Basically 46 meter, they're like, nope. This, to give you a context, how small 46 meter is, it's inside a run, basically football field. And most airports generally have taxiway longer than that. So basically this puppy is like, why taxi to the runway? What if I converted the runway into taxi? So like, how the heck they can be this, snappy, so to say? Well, if you design the craft, you have certain vectors to control. One of the vector is blown lift, meaning if you are blowing air over the wing will create lift. Lift is proportional to a relative velocity. Let that be clear. It has to be relative. When wing is here, air is flowing. It does not matter it's moving on the ground or not. Wing is independent of that. It only cares about how the airs are moving around it. Relative. Basically, it's almost like relative humidity. So if you have a plane that is lightweight enough and a good lift, and wind starts to blowing very fast, it will just take off. Direct vertical takeoff. It has happened. There are a lot of YouTube videos on that. So it's what we call blown lift. Now, all propeller crafts generally have that, where they can create lift because they are flowing air over the wing. So this puppy optimized that, and that's why they have 4 of that. So basically, they are utilizing the whole wing chord, and they are just like, oomping it. So it allows them to have like this hyper snappy takeoff. It's just like, yoy. So, and this also allows them very short landing, simply because they can drop the speed too much and do not worry about falling from the sky, because it's like wings are like, I got you. Why wings got you? Because the rotor is like, I got you. So this is the design philosophy that they are focusing on. So they do not have to worry about tilt rotor, and they do not have to worry about, oh, we need this runway and all that. They're like very snappy. Like, bruh, flyover is like, bruh, fly away from flyover. It's like, that's not an issue. So 8 motors. So really high powerful system. How much range? Yeah, this is where it gets sweet. 2000 kilometer. Yeah, now we are talking some serious aircraft. Like this is aircraft kind. Like at this point in time, you're not gonna have a discussion. This is a freaking aircraft with a ludicrously small takeoff distance, and that is with 45 minutes of reserve. Again, hinge rotors, they take a lot of energy. This is like, let's bypass that. So this puppy can do that. What is the speed? 300 km per hour. Now that's a bit slow, especially if you're comparing to jet, but more than good enough. And again, you're not driving 300 km per hour even on autobahn. So yeah, I know some people can try that. Most cars can't sustain 300. This is like, bruh, I can sustain this for 2000 kilometer. So there's a difference. So this is Electra's approach. Again, same turbo generator. Turbo generator stays as the sweet spot. What about the motor drain variability? Battery is like, I got you. So turbulence is like, motor have to fight for it. It's like, I got you. Battery is like, I got you. And turbo generator is like, I got the battery. So this is how it works. And again, if they focused on the shortening the runway part, like think about it, it's like the first sign is like, yeah, I'm out. It's like it gets bored of the runway. So it's Electra. Now we come to the turbo generator part of it, because again, it's cool and all, you can design the motors, done, propeller, done, airframe, done. How the heck you're gonna have the battery? Done. Okay, how the heck you're gonna have the power to charge the battery? Now we are talking for turbo generator. Now, thankfully, aviation industry already had this problem. They call it APU, meaning when you're talking about aeroplane, how the heck you cool it down? Assuming you do not have auxiliary services that are connecting pipes to you, how the hell you cool it down? You have a small generator, which we call APU. Now, why small jet engines? Because small jet engine is actually startable with basically battery power. You cannot start the main engine on battery power. So the tiny jet engine starts with battery power. That starts, spools up, creates a lot of pressure. That air pressure is now utilized to spin up one of the primary engine. So that's how normal commercial aviation works. So they always have APU system. And again, if you have both engine kaputting itself, APU will take up the load. If you are on a taxiway waiting, APU will take over everything. So APU is the one that takes care of most of things. So basically the plane lands, engines, once you coast out, engine starts to turn off. Basically once it's reaching an area where people would be around, so engine has to be off. So engine goes off, but again, you do need systems like cooling and a lot of other electronics. APU is like, I got you, fam. So we took APU and it's like, what if you make it run all time? Because APUs are really powerful. They are really robust, because again, that's the backup to the main engine. So they have very big, very robust, solid things. We just have to make them stable for long duration operation. Generally, APU is not supposed to be running, especially in flight. In flight, you're not supposed to use APU. Your main engine is like, I got you. If you have one engine failure, you may want to use APU. But again, something bad has happened if APU is on during flight. Maybe some plane has some different way, but most of the time, if APU kicks on, it's like rat deployment. It's like, no, you don't want that. So what kind of power rating we are talking about? 500 kilowatt to few megawatt. I've seen the biggest design around 2 megawatt. Now, is that a lot? Not really, but it's decent. It's a decent. Now, you have to understand the engine has to be designed in such a way that it breathes well in all altitudes. And the core aspect with this puppy is that it has to create basically shaft power rather than thrust. So whenever you're talking those big engines, those engines like push air through it, like so that's designed for that. That's why it's turbofan design. But here you want shaft, basically you want generator rotor to spin. So it has to have a different philosophy. Now, thankfully, we have a technology known as helicopters. They utilize this puppy. So helicopters have designed jet engines that are optimum for shaft power, not thrust, shaft power. So they are taking basically this company, Saffron, they just literally copy pasted their helicopter engine into this and just like, okay, we'll put a motor generator unit here. So that's what Saffron did. Rolls-Royce is doing another engine. So they have that, and Honeywell is also doing that, and Honeywell is already experienced with APU units. So they are like, we done, we good, we sorted. So all of them are just fine tuning it, nothing too major. And again, all you have to do is basically, if you are brand new engine, it has to be a helicopter engine. If it's a modification of APU, you just reinforce the component so it can sustain those load, and again remove the air compressor unit. Again, you do not talk, you're not expected to use compressed air in hybrid systems. So that's the difference change. And again, they are showcasing like what kind of designs they can utilize in. So Rolls-Royce is also very smart. It's like, yeah, if you want to smoke hydrogen, we can sell you. But they're very clear. If you are silly enough to buy it, I'm smart enough to sell it. Let that be very clear. They're very clear. They know for a fact that if you try with hydrogen, it will fly, it will give hipster some orgasm, but over time you'll be like, yeah, we are burning so much money and we're getting so little range. And now we understand why Air Force actually built, USA Air Force built a hydrogen-based fighter jet, and then why they cancelled it. Oh, Soviet Union built a jumbo jet on liquid hydrogen. They cancelled it. It's now in a museum. There is a reason for that. So let's just see. We always do the same thing. Like in 2020, Germany's gonna smoke weed and we're gonna launch hydrogen train. In 2022, we're gonna cancel the hydrogen train because it bankrupted us. Same thing will happen here. So let that be very clear. If you are stupid enough to buy hydrogen, I will be smart enough to sell it to you. Heck, I'm making an engine. I will sell it to you. So that's the whole point of it, turbo generator. So do not focus on the fuel, and ideally we'll use what we call sustainable aviation fuels. In that, even more ideally, seaweed biofuel. So this was my presentation on basically turbo generators. Hopefully, series hybrid topology of electric aircrafts. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.